Hi, I'm Kurt Oaknettle. I'm a product manager at Eurotech. I'm here to do the battle of the platforms. Amazingly, I'm going to talk about a platform. And look at this marketplace. A lot of platforms out there, and I think these are kind of the things that are inherent to all platforms. So, everybody says they're scalable, reliable, flexible, secure, multi-tenant. We really drive on open standards. Where we see ourselves is a term called iPaaS, and this means integration platform as a service. We don't think there's a magic bullet for one company that can do the whole thing perfectly. What we try to do is offer tools and a platform from a horizontal point of view that enables other companies and people who have experts on ERP systems, Salesforce, you have it. We're trying to enable those users from the cloud to the device, to the sensor. That's where we see ourselves, and that's what we try to really focus on in enabling and providing that content and expertise. And this is where we say the difference does matter on how we actually deliver this service and actually can enable this 50 billion devices coming out to the marketplace. Even if we all just get 0.1% of the business, that's 50 million devices, that's a lot of devices. There's a big marketplace. And our goal is really to try to make this marketplace grow fast. Like I said, there's not one magic bullet, so we're trying to provide the tools to enable this and enable the people to deliver this. And to do this, we think there's an open standards approach in trying to meet these requirements. So just from our cloud perspective, it's an open client. There's no client certification on devices. It's fairly easy to implement. MQTT is one of them. We use others as well. There's not a reason to say you have to have your device certified with us. It can be any device. You can connect in and start playing immediately. We don't want to own your data. We want to be a partner and integrate the data into your business enterprise. We're very simple. What's a data in, data out plan, amount of usage. We don't want to say there's a size of data, how much of data you can send, what the data format has to be. It can be a waveform, an image file. It can be any kind of blob. It can be key value pairs. It doesn't matter. Then another thing that's really something we really did and invested a lot of money on for our own is we also make gateways. Is we actually open source through the Eclipse Foundation a software framework to enable not only our devices, but whoever wants to use this framework to get them to market quickly. It's called Cur. I'll talk about that a little bit more later. And then we also sell or provide our platform not only as a service fee, but also for an on-premise solution. So you can actually put it in your own firewall, build the architecture within your own firewall, and that solution can be in your own system, out of our control, just a licensing model. You take the technology and you run. A secondary thing that we think really matters is the device management aspect. This is not necessarily the SIM management. This is the device management. Similar to analogous to smartphones, we want to be able to stop and start services, enable these devices, enable people to deploy services, manage the OS, manage the security, manage updates to the firmware. These things are really crucial and really actually quickly getting the system to be manageable. Putting 500 devices out there is not a huge deal. Putting 50,000 devices there without actually a true management system that's professional, has the right tool sets, really is inherently needed to actually control this. So just not a platform that just takes data in, but actually can manage updating those services. The other thing is, just another tool that we provide that's really inherent in M2M is getting somebody like an engineer connected to the device. We provide a reverse VPN tunneling application where it's a device initiated. You tap it, say, hey, I want to do a VPN. The actual device initiates a VPN in the cloud. You actually get a bridge from the cloud to your VPN server, so now an engineer can have command-line control behind firewalls where the device is located, and can maintain and manage that device. Quickly adding devices, zero config, very important. You don't need to touch the cloud. You can add a device ad hoc. It starts pushing data to the cloud. It's immediately available for your APIs and your back-end applications to actually retrieve that data instantaneously. And then latency is also important. For those applications where, let's say you're doing a garage door application, you want to open up your garage door, that needs to open instantaneously. So talking about Cura, this is something that we developed for our own gateways, but we've actually open sourced it in a partnership with Eclipse. It's under EPL license. The idea today, we have a lot of people in the world that are coming out of college, know Java, they don't know M2M. So we want them to be able to get an Arduino, a BeagleBone, quickly download from Eclipse an infrastructure, emulate it on a PC, write an application, run it, deploy it on a target, and start connecting and playing with the cloud. This is critical for growth. We need people that actually can play with this and get going forward. Just a quick overview of what Cura looks like from a standpoint of architecture. It kind of sits on top of Linux. There's an Oracle JVM. There's an OSGI framework. And it's actually, smart application bundles built in there that allows people to get lat, get long from a GPS device, connect cloud, manage your Wi-Fi. But it really allows a person from a construct in an open source environment to turn your gateway or your device at the endpoint into a smartphone-like device and deploy a service and write a bundle. So we want to be able to enable the community as a whole to start partaking into this so we can get that 50 billion devices out in the marketplace. So what I want to show you is something like where we ate our own dog food, in essence. This is a demo that I'll show here that we actually in partnership with Italian EPA groups and also the European Union and working on an environmental monitoring system. It's called the ReliaSense. Just a quick overview. There's a ReliaSense. It actually runs Cura and actually delivers data to the cloud using MQTT and then actually delivers data to web portals and backend applications on your handset, iPhone applications, as well as Android. So, what does it do? So in the ReliaSense, it actually has sensors and actuators that measure pollutants, electromagnetic fields, radioactivity. It provides real-time feeds, data streams from those sensors and actually connects them to the cloud for integration to ERP backend systems. And then actually there's web portals and backend applications. So just quickly looking at the architecture of the device, it's kind of interesting. This is a Java-enabled system using Cura that basically has a cellular connectivity component, a connectivity component that uses cellular, 3G, 2G, LTE, Wi-Fi, or Ethernet. It has an environmental analysis system for electromagneticity. We actually did a demo where we're in a trade show floor, and you can see during times when people are making phone calls or when they're not making phone calls, it actually monitors that sensitivity. It's radioactivity, it's temperature, humidity, pressure, and then also the air quality, CO2 and O2, and different sulfur, different components of that. So there's quite a bit of complex sensor management pieces within this device. But at the base, it's sensors, a framework, a connectivity piece. Sounds very familiar. The use cases for this, and this is kind of interesting, I was on a panel earlier this year and talking about smart cities. So a lot of this is smart city use cases where we're actually going in, monitoring the air quality through corridors, through by factories, by different applications where they're actually trying to monitor, make sure that they're following. And these use cases is where they can actually monitor if a factory is generating too many pollutants. It can actually be alerted fairly quickly, see if there's a problem, correct it. Really a lot of cities that actually want to compete with, we have a clean air city. The communities want to know that their area where they're at is clean. So we're trying to really provide a service or an application so they can actually monitor this in a real-time setting, not only for the business partners in the city, but also the communities around to make sure that they're living in a quality air environment. So to really go into the application, what was there in the first place. So what was typically there in the first place, as you can see, is a behemoth system that cost $400,000. Very stationary, accurate, has a lot of, the sensors cost about $20,000 a piece itself. provides data on a 30-day analysis, very high precision, but you can see it's very, very costly. And it's at a fixed site. So what we did with this is now we're trying to put in a system, in teaming with the Italian EPA, a solution that is connected real-time, provides real-time sensing, real-time alerts, and is mobile. So it can also be put on city buses and actually get a mesh environment and be dragged around the city and located and see actually environments at GPS locations where it's what the air quality is inexpensively. It's a 40x reduction in cost, which is an amazing solution now that we're trying to achieve. Easy to install, plug in a pole, mount it to a bus. Very easy to install. Another benefit is now that you have real-time applications to it, you actually can calibrate it over life. So as other sensors degrade over time, you can actually send updates and calibrate the device and make it extend its lifetime. Precision is still high and distribution is still wide. And just to show, so in showing you the web portal, this is a live look in northern Italy right now. Sensor online right now. It actually shows a map of the location. It actually shows live data feeds. You can pick aggregate of different devices, aggregate those devices, do reports, export raw tables of data, show a graph that actually you can pick a particular component over a period of time, map it, and see what it's looking like to see when is the high times of bad air quality. You can actually come in and update the settings for alerts. So if you are a manufacturer and you're looking to enable connectivity solutions in your manufacturing near a city, and you yourself can say, well, do I want to have this available so I might get caught? You can actually come in here and say, if I see it above this level, I need to know. So you can actually come in here and set settings on each individual component and actually get SMS alerts or email alerts based on each component and actually have this as a service. As we go into these different cities and communities, reducing the cost, they don't even have to buy the hardware. The service could be just like a phone service, where they actually go in and take the device and pay a monthly service fee and have no cost. The benefit of this is that it's from a holistic perspective, this is using our own dog food, and basically we're eating it. Having a current environment, having an enabled system, adding new services, deploying new services down using Cura is a great approach. It's also, we have iPhone apps and also Android apps that we can show you. I think that is it. Thank you very much.